Okay, question 1 then. So we start off with this gas in this container with this piston on top, and we have to explain in terms of particles how the gas exerts pressure on the piston. So we're going to be talking about the motion of the particles, and you want to be talking about how they're moving around inside the chamber here. Now if you simply mention that the particles, as they're moving around in here, they're going to collide with the piston, or they're going to hit it, then there's your first mark. So you need to be talking about how the particles hit the piston to push it up. Second mark is that will then result in a force being applied to the piston. So if you talk about the particles hitting the piston, 1 mark, and that is going to result in a force being applied to the piston, 2nd mark, and that is all there is in that question. Part B, we've squashed the volume into a smaller space, and we have to explain in terms of particles again why the pressure of the gas increases. It says, crucially, the temperature remains constant, so we know the particles aren't actually moving any faster. What we also know is that as this piston comes down, we've got a smaller space. So number 1, you can say that the density of the gas is going to increase, the particles are going to get closer together, they're going to get more crowded, that sort of thing. But for the 2nd mark, you need to be talking about how the particles are going to increase the rate at which they collide with the piston. And the reason for that is very simple. They have less far to travel down before they go back and hit the piston again. So they're going to hit it more times a second. Now, crucially, you can't say that they hit it more. You have to say it's more collisions per second, or we have increased the rate at which the particles collide with the piston. So it's the rate rather than just an increase in the amount of collisions. And then the final one, we've got this question here. It says use an equation selected from the list of equations at the end of this paper. So let's look. We have got the pressure, or the pressure is 103 kilopascals. The volume of gas is 0.010 cubic meters. And now we've got a new volume. So this was the old volume and the old pressure, and we were trying to work out the new pressure. So we want to work out what P2 is, and we're told what P1, V1 and V2 are. So we're looking in the back of the exam paper for an equation that has the pressure and volume before and after, and if you look at the back you will find it, there it is, just there. P1 V1 equals P2 V2. So that's pressure and volume of a gas at fixed mass at a constant temperature, which is exactly the situation we have here. So we're going to bring in the equation and we're going to solve it. You might remember that with this equation you don't actually have to worry about converting any of the units. Let's move that there. So here's my equation. I need to rearrange it to get P2, the pressure at the end, the pressure of the gas in figure 2. And to do that I just divide both sides by V2. So if I divide this side of the equation by V2, I'll just end up with P2. And this side of the equation, if I divide it by V2, I'll end up with P1 V1 divided by V2. So that gives me this line here. Substitute the values in. Like I say, it doesn't matter that this is kilopascals, it usually would. But with this equation, as long as you're consistent with the units, as in both pressures are in kilopascals, or both volumes are in cubic centimetres or whatever, it won't be a problem. So I've got P1 V1 over V2. P1 has to be my initial pressure. We're told that's 103 kilopascals there. That just means that the pressure I'm going to get is going to be in kilopascals. V1, the volume at the beginning, was 0.01 knot, and V2, the volume at the end, is 0.007 knot. Put the numbers in and stick them into your calculator. What you'll find is that it doesn't quite get you 150. So I'll just show you 103 times 0.010 divided by 0.007 knot will give you 100. Oh, no, I've missed something there. Let's see, 0.010. I probably missed a 0 rather. Yeah. Probably a dodgy calculator button, I would imagine. Definitely not my fault. So there's our answer, 147.14, yada yada yada. You know in physics you never give an answer to that number of decimal places. That is a ridiculous number of decimal places. You've got to round it to something. You're going to need to round to two significant figures. The reason that you're going to round it to two sig figs is because this is to two sig figs and this is to two sig figs as well. And whilst this is to three significant figures and therefore slightly more accurate, the accuracy is determined by your worst reading. So it's going to you're going to round to the number of significant figures that we've got here. Two significant figures for that number you've just seen will be 150 kilopascals. You'll notice that the unit's already given for you there, so no need for a conversion. So in terms of marks, it was 1 for rearranging, which is that part there, 1 for substitution, which is that part there, and 1 for the evaluation to two significant figures. You had to do the rounding in order for that to be true. And that is your first question.